Today we are going to learn about mastering Python JSON serialization techniques. You will gain advanced skills in efficiently converting complex Python objects into JSON format for seamless data exchange. Welcome to this video on mastering Python JSON serialization techniques. Serialization is the process of converting a data structure or object into a format that can be easily stored and transferred. JSON, which stands for JavaScript Object Notation, is a lightweight data interchange format that is easy for humans to read and write, and easy for machines to parse and generate. In Python, JSON serialization is crucial for data exchange between applications and systems. Throughout this video, we'll delve into how Python handles JSON serialization, starting from the basics to more advanced techniques. By the end of this session, you'll be well equipped to serialize complex Python objects into JSON efficiently, opening up new possibilities for application development and data management.
The JSON module is a built-in library in Python that provides an easy way to work with JSON data. To serialize a Python object into a JSON string, we use the json.dumps function. This function converts Python objects such as dictionaries, lists, strings, integers, and floats into a JSON string. For example, if we have a dictionary representing a user with keys like name, age, and email, we can serialize this dictionary into a JSON string using json.dumps your dictionary. Similarly, to write this JSON string to a file, we use the json.dump function, which takes the object and a file object as arguments. Understanding these basic functions is crucial, as they form the foundation for more complex serialization tasks. It's important to note that JSON supports a limited set of data types, which are closely related to Python's basic data types. These include strings, numbers, objects, arrays, and booleans.
When dealing with custom Python objects, serialization can become more challenging since JSON doesn't natively support Python classes. However, the json.dumps function offers a solution through the default parameter. This parameter allows you to specify a custom function that Python will call whenever it encounters an object it doesn't know how to serialize. For instance, if you have a class called employee with attributes like name, age, and position, you can define a default serialization function that converts the employee object into a dictionary containing these attributes. You then pass this function to the default parameter in json.dumps. This approach provides flexibility in how custom objects are serialized, but it has limitations. The custom function must return a JSON serializable object, and complex nested objects may require additional handling.
For more control over the serialization process, Python provides the JSONEncoder class, which can be subclassed to handle complex objects. By overriding the default method of the JSONEncoder class, you can define exactly how different types of objects should be serialized. This method should return a JSON serializable version of the object or raise a type error if it cannot serialize the object. For example, if you have an object that contains a datetime attribute, you can subclass JSONEncoder to convert this attribute into a string format that JSON can handle. Subclassing JSONEncoder provides a powerful way to manage serialization, especially when dealing with large and complex datasets, as it allows for a clean and maintainable codebase. This method is particularly advantageous because it centralizes serialization logic within a class, making it easier to manage and extend. In Python, not all data types can be directly serialized into JSON. Types such as sets, bytes, and complex numbers are non-serializable by default. Identifying these non-serializable types is the first step in dealing with them. One strategy is to convert these types into a serializable format before serialization. For instance, you can convert a set into a list or a bytes object into a string using base64 encoding. Another approach is to create custom encoders for specific data types, as we discussed earlier with JSONEncoder subclassing. It's also important to handle errors gracefully. When attempting to serialize non-serializable types, Python will raise a type error. By catching these errors and providing a fallback serialization strategy, you can ensure that your application remains robust and error-free. These techniques are essential for working with complex data structures and ensuring seamless data exchange in real-world applications. Performance is a critical aspect of JSON serialization, especially when dealing with large datasets or high-frequency serialization tasks. Optimizing serialization can lead to significant improvements in efficiency and application responsiveness. One technique is to minimize the complexity of the objects being serialized. Simplifying data structures can lead to faster serialization times. Another approach is to use third-party libraries like json or simplejson, which are optimized for speed and can outperform the built-in JSON module for certain tasks. However, it's important to balance speed with readability. JSON is often used for data interchange between systems, and overly complex or compact JSON can become difficult to debug and maintain. Profiling and benchmarking your serialization process can provide insights into potential bottlenecks and areas for improvement. By applying these optimization techniques, you can ensure that your JSON serialization is both efficient and effective, even at scale.
While JSON serialization in Python is powerful, there are common pitfalls that developers should be aware of to avoid errors and data loss. One common error is attempting to serialize non-serializable data types, which can be mitigated by implementing custom serialization functions or encoders. Another pitfall is data loss due to precision errors, especially with floating point numbers. Ensuring that your data maintains its integrity during serialization is crucial, which may involve using custom serialization logic for precision-critical applications. Circular references, where objects reference each other, can also pose challenges, as JSON does not support them inherently. Strategies such as reference counting or converting references to unique identifiers can help mitigate this issue. Lastly, ensuring compatibility across different systems and versions of Python can prevent serialization errors, especially when dealing with diverse environments. By understanding and preparing for these common pitfalls, you can ensure smooth and error-free serialization in your applications.
JSON serialization is widely used in various real-world applications, making it a valuable skill for developers. One common application is in web APIs, where JSON is the de facto standard for data exchange. By mastering JSON serialization, you can create robust APIs that efficiently handle requests and responses. Another application is in configuration files, where JSON is used to store and load configuration settings for applications. This allows for easy modification and maintenance of configurations without altering the codebase. Data storage is another key area, where JSON serialization enables the storage of complex data structures in a human-readable format, facilitating data interchange between different systems. Through case studies, we can see how companies have implemented JSON serialization to improve data interoperability and system integration. Learning from these examples provides valuable insights and best practices for implementing JSON serialization in your projects. By understanding these real-world applications, you can leverage JSON serialization to enhance your development processes and create more efficient and maintainable applications.
As we conclude this video on mastering JSON serialization techniques in Python, let's recap the key points we've covered. We started by understanding the basics of JSON serialization using the JSON module, then explored handling custom Python objects and the power of JSONEncoder subclassing. We tackled the challenges of non-serializable data types and discussed optimization techniques for performance. We also identified common pitfalls and how to avoid them. And finally, we looked at real-world applications and case studies. JSON serialization is an essential tool for data exchange, and mastering it expands your capabilities as a developer. I encourage you to practice these techniques in your projects and explore further learning opportunities to enhance your skills. Thank you for joining this session, and I hope you feel more confident in your ability to serialize complex Python objects into JSON.